All right. Here are the topics for review. And you should get a paper. It's already shared on, I'll share this on Google Drive and Google Classroom. Anyway, we're going to go in a very strange order. It's in the order that I just decided that we're going to do today. So the first one that we're going to take a look at is question number 11. Question number 11 is recognizing which product is the precipitate. So let's take a look at number 11 right now. Number 11, recognize which product is the precipitate. How do we know which one is the precipitate? The precipitate is the product. First of all, it's a product. It's a product that does not dissolve. And so imagine that there are two things that are mixing. And what are the things that we know about compounds? All nitrates dissolve. All nitrates dissolve. So let me give you a compound that was not on the lab the other day, something called barium nitrate. Imagine you have barium nitrate, and barium nitrate's formula looks like this, and you mix that with something called potassium sulfate. And there's the formula potassium sulfate. And this is a double displacement reaction. The barium will now go with sulfate, and the potassium will now go with nitrate. First of all, that's not balanced. I can tell right away because there are two potassiums on the reactant side and only one on the product side. Therefore, there must be a 2 here. So that takes care of the K. That also doubles the number of nitrate groups right over here, so which is great. Now it's all balanced. Barium 1, nitrate 2, sulfate groups balanced. So here you go. Now, if you know that a precipitate formed, and by the way, if you mix these two substances, these two clear liquids will form something like a whitish tan color. So a precipitate definitely formed. Which one of the products then is the precipitate, Jai? It must be this. How did you know that? Because this nitrate cannot be a precipitate because it's a nitrate. Therefore, it's just the process of eliminating one of them. That's a review of how you know which one is the precipitate. The precipitate is the one that essentially that's not a nitrate. And it needs to be a product. So please don't say that barium nitrate is a precipitate. It's not a product. Please don't say that potassium sulfate is the precipitate. It's not a product. It must be one of the things that are formed, the products, right? So that's number 11. That's number 11. How to recognize which product is the precipitate. Number 11. Today on April 19, done. Right? The next one, this one will take the most time today. This one will take the what? Yes, of course. That's your paper. But there's no way that you can do all of this on that paper. You should be copying this in your notes if you want to be part of the review. If you want to take notes during the review. Yeah. Right in the front. You came late. We're going to go over the quiz. That, I believe, can really help you a lot for the quiz today. I mean the finals. The most recent quiz that I just returned. I'm not going to go over number 1 because practically every person, except for one, got 100. Got perfect on number 1. Your question? Yes, every single one. It's 14 pages of questions. So here we go. This is question number 2 in the quiz. The quiz that I just gave back. If you got 100, good for you. If you didn't, most people did not get 100. Here we go. What is the molarity of a solution? When you're calculating molarity, you need to do exactly what you need to write. You need molarity is the moles on the top and the liters on the bottom. You see, the problem with most of the kids who did not do well is that they just decided to do it the way they wanted to do it, or the way they thought that they should do it. No, they're not doing it the way that I told them how to do it. And obviously, they're not going to do very well. You need to know the moles and the liters. So here we go. The question now is 15.3 grams of lithium chloride in 125 milliliters solution. When you have grams, 15.3 grams, you need to right away think about making those grams and converting them to moles. Most kids didn't even bother to write the step. And then they wonder why they didn't do very well, because they didn't bother writing the steps. They also did not bother writing the formula, lithium chloride, LiCl. Lithium chloride is LiCl because lithium is positive 1 and chloride is negative 1. And when you convert from grams to moles, we're going to put grams on the bottom of the conversion because that's what we're trying to get rid of. And we're going to put moles on the top because that's what we're looking for. 1 mole is. This relationship between moles and grams is the molar mass. So you have to understand that there's 1 lithium and there's 1 chlorine. Lithium happens to be 7 grams per mole, and chlorine happens to be 35 grams per mole. 7, 35, 42 grams. 42 grams is 1 mole. Grams cancel out and we're left with moles. If you got 100, good for you. If you didn't, check your work. Understand why you didn't get 100. Therefore, the work for the calculator is 15.3 times 1 divided by 42. And the answer is 0.364 moles of lithium chloride. Well, that's just the moles. So now do you know the moles? Sure you do. It's 0.364 moles. Do we know the liters? No, we don't. We do know the milliliters, though. So 125 milliliters. And we're going to put milliliters on the bottom, liters on the top. 1 liter is 1,000 milliliters. Milliliters cancel out. We're left with liters. That's 0.125 liters. Now do we know the liters? Sure we do. 0.125 liters. And now, because you know the moles, and now because you know the liters, you can calculate the molarity. Essentially, it's 0.364 divided by 0.125. 3-digit answer is 2.91 molarity or molar. That's how you calculate molarity, especially if you're given the grams and if you're given the milliliters. Convert the grams to moles, convert the milliliters to liters. That's the way to do it. That's question number 2. Question number 3, most kids got wrong. How many grams of potassium sulfide are needed? First of all, the main reason why many kids got this wrong is they did not write the correct formula of potassium sulfide. Potassium is positive 1, sulfide is negative 2. You need 2 potassium to be involved. That's the formula of potassium sulfide. So, how many grams are needed to produce 375 milliliters of a 0.025 milliliter solution? You see this is a milliliters, needs to be converted to liters, right? So the milliliters, whenever you see milliliters, you need to convert that to liters. So 375 milliliters. We put milliliters on the bottom, liters on the top. 1 liter is 1,000 milliliters. That's 0.375 liters. Now we know the liters. And now we can convert those liters to moles. I definitely taught you about this conversion. Liters to moles conversion using molarity as a conversion factor. 0.375 liters. Put liters on the bottom and moles on the top. And we're talking about potassium sulfite. Well, here's the relationship between moles and liters. It's right here. That's what this capital M means. This capital M means that there's 0.225 moles per 1 liter. That's the meaning of the molarity. And if you did that, you can now cross out the liters and you're left with moles. And the calculator work is 0.375 times 0.225 divided by 1. And you get a 0.08435. Why am I carrying so many digits? I'm carrying so many digits because at the end I can round it to 3. Now if you want to round this, you can certainly round it to 0.0844 moles of K2S. We've now been able to convert from liters to moles. But the question says, how many grams? So in order to get the grams, you need to do a moles to grams conversion. Again, certain students who did not do well did not bother writing down the name of the step. They didn't understand what was the next thing to do. When you have moles, you can convert moles to grams. 0.0844 or 0.084375 moles of K2S. Let's put moles of K2S on the bottom and grams of K2S on the top. And you realize, whoa, that's the relationship between grams and moles. That's what you need to convert from moles to grams. You need a molar mass. And the molar mass of K2S is that there's 2 Ks and there's 1 S. K happens to be 39 grams per mole, and sulfur happens to be 32 grams per mole. That's 40 minus 2. 78. Oh, it's a nice, beautiful 110 grams. 110 grams is 1 mole. Moles cancel out. Therefore, we're just going to take 0.0844 times 110 multiplied by 110 and then divide by 1. And the answer is 9.28, but more importantly, grams of K2S. And so, how many grams of potassium sulfite are needed? 9.28 grams of potassium sulfite are needed. Check your work so that you can understand where you may have made a mistake, right? These very similar questions are going to be on the final exam. Question number 4. Let me tell you, half the class did not get this right. I'm concerned about that. How many liters of a 0.188 molar solution of sodium phosphate will provide 0.675 moles of that substance? You know the moles. The moles is right here. The moles is 0.675, and we're looking for liters. When we're converting from moles to liters, right? When we're converting from moles to liters, you use the molar mass. I mean the molarity, sorry. You use the molarity. So moles. You have to start with 0.675 moles. This is where most students made a mistake. They started with the molarity. We never start with the conversion factor. We always start with what's given. What's given is 0.675 moles of sodium phosphate. This happens to be Na3PO4. We're going to put moles on the bottom to cancel that out. And we're left with liters sodium phosphate on the top. Therefore, we know that this is the relationship between liters and moles. And the relationship between liters and moles is the molarity. We use molarity to convert from moles to liters. 1 liter is 1.88 moles. Moles cancel out, and now we only need a calculator. 0.675 times 1 divided by 1.88. We need a 3-digit answer, and that happens to be 0.359, and it's liters. And so the question said, how many liters? The answer is 0.359 liters. This is a moles to liters conversion using molarity as the conversion factor. You don't start with molarity. Can I just write that down now? You don't start with molarity. Don't start with molarity. The molarity is a conversion factor. You need to start with what's given to you. In this case, 0.675 moles was the information in the question. That's the given. So let's apply that statement. You don't start with a molarity in question number 5. How many moles are in 465 milliliters of a 0.735 molar solution of rubidium bromide? First of all, this is RB, BR, because RB is positive 1, BR is negative 1. There it is. Anyway, here's the thing. That's milliliters. You need to, whenever you see milliliters, convert those to liters. And so 46.5 milliliters, we can convert from milliliters to liters. 1 liter is 1,000 milliliters. Milliliters cancel out. We're left with liters. 0.0465 liters. And what can we do now? If we know the liters and we know the molarity, we can convert from liters to moles using the molarity. Never start with molarity. Molarity is a conversion factor. You start with what's given. 0.0465 liters of RBBR and we're going to put liters on the bottom, and we're going to put moles of RB, rubidium bromide, on the top. Moles per liter. Oh, that's the molarity. That's that molarity right there. 0.735 moles per liter. Liters cancel out. We're left with moles of RB, rubidium bromide. It's a very small number because 0.065 0.0465 times 0.735 divided by 1 gives us 0.0342 moles of rubidium bromide. 0.0342. Now watch what happened. I'm going to confuse you a little bit. Somebody did not bother to convert milliliters to liters. They just used this straight up like this. They said 46.5 milliliters, and then they put liters on the bottom and moles on the top, 0.735 moles of RBBR. And then they did this calculation. Obviously, this is wrong. Why am I showing this to you? That way you can avoid this in the future. 0.735 divided by 1. They got 34.1. Somebody actually wrote that as their answer. 34.1 or 34.2 moles. Look at how similar these look. 342 and 334.2, 0.0342. They're 1,000 times different than each other. This is wrong. Why? Because it's milliliters. They forgot to convert milliliters to liters. Right? So that is the review for this part. Oops, sorry. For this part of the review, which is all the stuff that has to do with solutions, except for one part, stoichiometry of solutions, which we'll do on Monday. So, just as a reminder, I'm going to do this part, stoichiometry of solutions. I'm going to do that on Monday. But all of the other ones, I've already done. Number 10, completed.